So we've been looking at different types of graphs. We looked at all sorts of terminology. So now we want to actually work some classification exercises. Basically here we're going to classify the different types of graphs that show up. So here's your exercises. Determine if the graph has directed or undirected edges, first of all. Second of all, whether it has multiple edges, so yes or no, does it have multiple edges? And third of all, does it have loops, yes or no? Use your answers to these three questions to classify the graph. All right, so first of all, I'm going to do a little A. Directed or undirected? Undirected edges, right? No arrows. So it doesn't matter if we go from A to B or if we go from B to A, either way. All right, part C. Multiple edges? No multiple edges, right? We don't have any repeated edges. No multiple edges. That was what? Let's call that B. C. Loops? No. No loops. This guy has no loops. So based on that information, that would be what? A simple graph. Just an ordinary simple graph. A graph, no multiple edges, no loops is a simple graph. You could call it an undirected simple graph, but simple graph for sure. All right, number 2. Another example. Here we go. Here's a dude. A, B, C, D. And here we go. Drawing the picture. Not going to talk. All right, there's our graph. So first of all, does it have directed edges or undirected edges? Undirected, right? No arrow showing up here. Undirected. Order doesn't matter how we move along the edges. So they're undirected edges. What else? Do we have multiple edges? Hey, yeah. We got multiple edges, right? CD is repeated. CD has multiplicity 3. So part B, CD is an edge of multiplicity 3. So it's repeated, right? All right, what else? Do we have any loops? No loops. No loops. Let's call that C. No loops. So we have a graph that has multiple edges but no loops. It's an undirected graph. So we call this a multigraph, right? It's an example of a multigraph. All right, this is a number 3. Here's our picture. We got A, B, C, D. 4 vertices. Connecting A and B, connecting A and C, connecting A and C, connecting B, C and D, and connecting D to itself. Oh, and connecting B to C as well. All right, so first of all, first question we're going to ask, is it directed or undirected? It's undirected, right? There are no arrows. Undirected. Doesn't matter how we move along the edges. Undirected edges. B. Do we have any multiple edges? Yeah, actually we have what? AC is repeated. So AC has multiplicity 2. That's a multiple edge. All right, do we have any loops? Actually, we do, right? Yes, D is a loop. Singleton D. D goes to itself is a loop. All right, so what happens when you have undirected graph? You have repeated edges, multiple edges, and you have loops. You call this what? A pseudograph, right? A pseudograph. What else do we want to draw here? Thinking. Let's see. So we're going to start off with, let's call the point. Let's just call it, change it up. V1, V2. Let's do here V3, V4. Let's just get fancy with the arrows, right? Draw some arrows here. All right, first of all, do we have directed or undirected? Or is it mixed? Could be both, directed and undirected, both. It's only directed, right? Directed edges only. We don't have any undirected edges. Directed edges. B. Do we have any multiple edges? You might be tempted to say, yeah. I mean, if you think about like V1, V3, that's different than V3, V1, right? Those are different edges. Likewise, V4, V2 is different than V2, V4, right? Because the order matters. So, no multiple directed edges. No multiple directed edges. So we have to specify directed here, because we're dealing with directed edges. And C, do we have loops? No loops. So what do you call a directed graph that has no multiple edges, no loops? This is called a simple, right? Simple directed graph. Or you could just call it a directed graph, but simple directed graph is the most accurate. All right, what else? Okay, this will be my last example. Getting tired of doing this. 5. Okay, we got V1, V2, V3, V4 again. Let's do edge here. And let's see, one here. Pay attention to the arrow. Let's see, one here. Let's say one going in this direction, V3 to V4, and then we got one going in that direction. All right, so there's our graph. Part A. Is it directed, undirected, or both? A little bit of both. It's all directed, right? Everything's directed. Only directed edges. Every edge has an arrow, directed edges. B. Do we have any multiple edges? It turns out we have one multiple edge, right? V1, V2 has multiplicity 2, right? So V1, comma V2, that directed edge has multiplicity 2. So it's a repeated edge. Repeated directed edge, I should say. And do we have any loops? Actually, there are no loops here, but that's all right. So what do you call a graph that has what? Directed edges and has a multiple directed edge? May or may not have loops. Doesn't matter if it has them or not. This is called a directed multigraph, right? A directed multigraph. Remember that term? Presented that in an earlier video. Directed multigraph. Okay, so I think I'm going to be done here with classifying. That's 5 examples for you. All right. So I think that'll complete this section, and we'll pick up in the next section with more terminology, but get a little more detailed maybe.